Okay. Can you hear me?
জি স্যার।
জি স্যার, শুনতে পাচ্ছি।
ওকে, আমরা এস্টিমেশন থিওরি পড়ছিলাম। আপনারা যদি খেয়াল করে থাকেন যে আমরা এস্টিমেশন থিওরির আজকে লাস্ট টপিকটা পড়ব, যেটাকে বলে বেসিয়ান এস্টিমেশন। এর আগে আমরা আপনাদেরকে বলেছি যে এস্টিমেশন কি, estimation types of estimation. That is, we have two types of estimation in general. That is point estimation and interval estimation. And then in a point estimation, how we can find a good estimator. That is, some find properties of a good estimator. When you find the estimator, that should be unbiased, that should be consistent, efficient, at the same time sufficient if you find them. Unless you should find some estimator at least following the first property or first two property or first three properties or first four properties if possible. But based on the strongness of the property, this is a range. And another estimation procedure we have, that is we call Bayesian estimation. In broad sense, we call it Bayesian statistics. But the basic difference is that in general estimation theory, we have x when we write a density function, or when we write a PDF. Say when you write a PDF, how you write a PDF? That is, you write a PDF, say f of x, okay, f of x, like this, f of x. That is, this is the density function, and theta is the unknown. Okay, theta is that unknown quantity. So always we know this x, that is data is given. This x is known. We want to predict this theta. We want to know this theta because these thetas are unknown in the population. In Bayesian estimation, this theta is the parameter. Okay, this theta is unknown. This theta is the random variable rather, and this x is known. Okay, so it is the other way, that in classical estimation theory, x is the random variable, theta is the unknown parameter we want to know. But in Bayesian estimation or Bayesian statistics, this theta is the random variable. It varies from case to case, and this x is known. So this is the basic difference. And this Bayesian estimation is also coming from the Bayes theorem we studied. Okay, that is, in Bayes theorem we have a prior knowledge. We call it prior probability, or simply a prior. So that is another thing, that in Bayesian estimation we have some degree of belief that is known. Okay, Bayesian statistics is a theory in the field of statistics based on the Bayesian interpretation of probability, where probability expresses a degree of belief in an event. The degree of belief may be based on prior knowledge about the event, such as the results of previous experiments, or on personal beliefs about the event. So in Bayesian statistics, this prior knowledge, or we call it simply a prior, okay? We usually get this information in terms of prior distribution, okay? যে prior যে data সেটা আর যে information তার যে distribution হয় সেটা হচ্ছে আমাদের prior distribution. So you knew about this conditional distribution, okay? And from there we learned this Bayes theorem, okay? So when we calculate this Bayes theorem, if you can remember, we calculated this probability of BR and that was given. This probability of BR is that prior probability, okay? And we actually going to calculate the posterior probability, they call it, with the help of this prior probability. So the information that is known in advance, that is the prior probability, and this is coming from the Bayes theorem. So that Bayesian estimation is actually upgrading knowledge based on that prior information. First, we want to define this Bayesian estimation first. That Bayesian estimation is also called that Bayesian most probable estimate of the unknown, but true value theta 0 of the parameter theta is that value theta hat that maximize the posterior distributions probability mass function or probability density function phi of theta x. You see, if you closely see this, this is they call it Bayesian most probable estimate of theta. But this is theta given x, not x given theta. In classical estimation, we write phi of x given theta or f of x given theta. Theta is unknown, x is random variable. But in Bayesian estimation, theta is random variable, x is known. Phi of theta x is actually any function of theta that given x. Hence, the Bayesian most probable estimate is given by phi of theta hat given x equals supremum of phi of theta x, okay, theta in the sample space. So we are looking for that best probable estimate. For example, let x1, x2, xn be a random sample from the binomial distribution with m and theta parameter, okay? Can you remember we learned it as binomial np, okay? np, but here they call it mp. It can be any notation, okay? But it is almost the same, that n is that number of trials, theta is the probability of success. And assume a beta, alpha beta prior distribution for theta, okay? So the prior information is given that it is a beta distribution with alpha beta, okay? Find the Bayesian most probable estimate given the sample results x equals x1, x2, xn, a random sample, okay? So given a prior information that is beta distribution of alpha beta, আপনারা এটা ম্যাথমেটিক্সে পড়ে আসেন যে বিটা ডিস্ট্রিবিউশন অফ আলফা বিটার একটা ফর্মুলা আছে। আপনারা জানেন যে আমরা বাইনোমিয়াল ডিস্ট্রিবিউশন আপনাদেরকে পড়িয়েছিলাম। কাজেই you can write the PDF or rather PMF, as this is discrete distributions. You can write it. So firstly, when we want to calculate the posterior probability, this one, we need the joint distribution of the original distribution, okay? At x1, x2, xn, a random sample of binomial distribution. So we want to find the likelihood function of it. That is actually the product of all the independent mass function, okay? So এটা হচ্ছে সেই binomial distribution এর mass function. So if you product it for n times, that is the likelihood function of that original sample. Okay, so it is actually the product term. So product term with some constant, we want to subtract that constant, so we write it as proportion. Okay, that constant we don't need it other than this difficulty in the expression. So we actually leave this constant terms. We are interested in theta only because we want to estimate the theta. So we write proportionate sign rather than equal sign to indicate that we lost some constant term to be equal. So we write it proportion. Okay, and this summation is going to power because of this is in a power. Okay, theta to the power summation of xi 1 minus theta to the power summation of m minus xi, as m is constant, so it is actually nm direct multiplication. Okay, so when we calculate the posterior distribution, it is actually the formula is proportionate to likelihood function multiply that prior distribution. Okay, so likelihood function multiplication of prior distribution will produce that posterior probability that is we are looking for. Okay, so we got this likelihood function from here. I put it here, and then the prior distribution of beta kind. So this is the prior distribution. We're multiplying it and considering theta to the power t, that is summation of xi equals t. Okay, to indicate that functional form a bit easier. Okay, next is some algebraic manipulation. You see theta to the power t, theta to the power alpha minus 1, so they come close together, and 1 minus theta to the power, we have these two powers, so they come close together, and this constant term also vanishes because of this proportionate sign, as we want to deal with this theta only because we are looking for the estimate of theta. So here we have written that t equals summation of xi, and that is posterior distribution is beta with alpha plus t and nm minus t plus beta. Hence, we know this is the posterior distribution. Okay, this is also can be written in terms of beta distribution. Okay, you know that it is actually coming from the mathematics. Okay, so when we are looking for, this is the posterior distribution. So if we ask you to calculate the posterior distribution only, the answer will end here. Okay, that posterior distribution is here, but we want to find that optimum or maximize that theta values. Okay, the posterior distribution with respect to theta. So as it is in power, we take logarithms and then differentiate with respect to theta to find the maximum. Okay, so this is the case when we want to find the maximum value of it. We want to find the first derivation xi equals to 0 and to find the second derivation and say whether that is minimum. So that will produce a maximum. Okay, that is a decreasing function or not. If it is a decreasing function, that says that it is a maximum exists just before that point. So we want to find the first derivation. We take logarithm, and you know when you take logarithm of this, it is actually log of 1 minus theta. So alpha plus t minus 1 divided by theta. Log theta কে differentiate করলে theta হয়, আর এখানে log of 1 minus theta কে differentiate করলে negative of 1 minus theta হয়, কাজেই এটাকে আমরা 0 বলছি। এবং এখান থেকে ইজিলি আমরা এটাকে এই ডান পাশের এক্সপ্রেশনটাকে যদি আমরা 0 বলি এবং সেখান থেকে ইকুয়েট করে আমরা থিটার এস্টিমেটটা বের করতে পারি easily, that is theta equals alpha plus t minus 1 divided by nm plus alpha plus beta minus 2. So that is the estimate, that most probable estimate, Bayesian most probable estimate of theta. Okay, so this is how Bayesian estimation is done with the help of the prior distribution. So with this problem, the given information, you see that we assume a beta distribution, prior distribution for theta. So the information that is known in advance, that is the prior distribution. We are calculating the posterior distribution, that is actually the multiplication of my say likelihood function and prior distribution. So they call this one is the prior distribution and this one is the posterior distribution. Okay, and likelihood function in the middle to calculate the product of all independent probability function. Okay, so this is the Bayesian estimation and Bayesian most probable estimate. To find the definition of prior distribution in text, if you are interested, that in Bayesian statistical inference, a prior probability distribution, often simply called the prior of an uncertain quantity, is the probability distribution that would express one's beliefs about this quantity before some evidence is taken into account. For example, the prior could be the probability distribution representing the relative proportions of voters who will vote for a particular politician in a future election. Okay, so if you take a random sample, you can also estimate that prior distribution. But in general, it is actually known in advance. Okay, if you consider that this certain political party, the proportion of voters they got voted for them in previous election, that could be the prior distribution. Okay, posterior distribution is of a random event or an uncertain proposition is the conditional probability. Okay, so this is the conditional probability, like it is coming from the Bayes theorem, that is assigned after the relevant evidence or background information is taken into account. Okay, so when you actually calculate the probability multiplying the likelihood function and prior, so this is the conditional probability as in Bayes theorem. So hence the name is coming that this is actually Bayesian estimation. Okay, as this is coming from the Bayes theorem. Do you have any question? So in this chapter, we actually learned about that estimation theory, that is point estimation and interval estimation. We talked about how this estimation theory is different from the descriptive statistics. Okay, how statistical inference and descriptive statistics constitute the subject statistics as a whole. We also talked about that statistical inference is the core area of the subject statistics as a whole. Okay, and as you will proceed in your learning, if you go for higher studies or if you do some PhD, you will see that you have to deal with this statistical inference or estimation theory to a great deal. Okay, so forget not how to calculate that point estimation of a single value and or interval estimation. Okay, so in general you know it. Okay, by this time. So this is the end of estimation theory. We will go to a a new chapter. We'll go to sorry. Have anyone of you trying to ask a question? Someone raised hands. কার কোনো কোশ্চেন আছে? কেউ কি কিছু জিজ্ঞেস করতে চাচ্ছিলেন? Okay, possibly not. Next chapter is test of hypothesis. This is a very important chapter in statistical inference. As you go, you have to learn. You have to learn if you want to stay in the field of study or research. Okay. So in test of hypothesis, we have to learn these 4 testing statistics. Okay. We have normal test, we call it, or Z test in general. T test, it is also known as the small sample T test. Chi-square test is known as chi-square. This is the sign chi-square, a Greek letter, chi-square. You see, this sign is chi and then a square. So chi-square test is also can be notation by this chi-square test. This is also known as the association test. Okay, and F test is known as Fisher's F test. Okay, this F is coming from the name Fisher, R.A. Fisher, who is known as the father of statistics. We will discuss about that in a later time. So in test of hypothesis, you have to know about what is hypothesis, what is a test of a statistical hypothesis. We will learn a bit about null hypothesis and alternative hypothesis, simple hypothesis and composite hypothesis, type of test, one-tailed test or two-tailed test, 2 types of error in testing hypothesis, part of the test, some critical region or rejection region, acceptance region, and test statistic. First, we want to say about what is hypothesis. Okay, a statistical hypothesis is an assertion or a statement about a population. You know about what about a population. Okay, you know by this time that population is actually the aggregate of all possible subjects under consideration. So if you claim something about that population, that is a hypothesis. Okay, about the probability distribution characterizing a population, which I want to verify on the basis of information contained in a data. So sometimes the population is represented by a population distribution, by a probability distribution. Okay, so if you want to, if you make a claim about that probability distribution, that is also your hypothesis. Okay, for example, a rickshaw puller hypothesizes that more than 50% of our politicians are corrupted. Okay, so this is a crude guess that that might be true, that might be wrong, but we can test that based on the sample. Okay, so this claim based on some information they have, that is hypothesis. Okay, you should have some ground based on your claim about the population. Okay, so that is your hypothesis. So a test of a statistical hypothesis is a 2-action decision rule. After the experimental sample values have been obtained, the two actions being the acceptance and rejections of the hypothesis under consideration. So what is a statistical hypothesis? Statistical hypothesis is a test of a statistical hypothesis is a two-action decision rule, that is based on which you can say your hypothesis is rejected or accepted. Okay. Before that, you have to collect a random sample. Null hypothesis is the statement that tells you that no difference exists between the parameter and the statistic being compared to it. Okay, that is the first hypothesis we want to make. Okay, you know that between a parameter is actually a population constant. Again, a statistic is calculated from a sample. So null hypothesis says that there is no difference between parameter and that statistic value, or otherwise there is no difference if you take subtraction between the parameter and the statistic, that is actually the difference is 0. Okay. Can you see it?
No, sir.
No, sir. Sharing off
There is a message showing that you are not presenting. What does that mean?
Sir, sharing হচ্ছিল, off হয়ে গেছে।
হ্যাঁ, ওটা একটু টেকনিক্যাল প্রবলেম হয় মাঝে মাঝে, as we are using a connection that is not very secure in Bangladesh, so sometimes it happens. Okay, so we are talking about null hypothesis. You can see now, right?
জি স্যার, এখন দেখতে পাচ্ছি।
Okay, so আমরা প্রথমে যে হাইপোথিসিসটা ধরে নিব সেটাকে আমরা বলবো নাল হাইপোথিসিস। ওকে, এবং আমরা নাল হাইপোথিসিসটাকে সবসময় ইজ নট দিয়ে রিপ্রেজেন্ট করি। ওকে, এবং অল্টারনেটিভ হাইপোথিসিস হলো যখন উই ক্লেম সামথিং লজিক্যাল অপোজিট টু দ্যাট নাল হাইপোথিসিস, we represent it by H1 or HA for alternative hypothesis. Okay, this 0 null hypothesis says not, that means null. Okay, 0 is null. Okay, that is there is no difference or is coming from that 0 is the null hypothesis. Okay, so if you say that more than 50% of our politicians is corrupted, that is your null hypothesis. Alternative hypothesis can be that more than 50% say it is not equivalent. Okay, that is not true. That is maybe that can be our alternative hypothesis. Okay, there exists significant difference in the population between the rates of prevalence of malnutrition between the male and female children. Okay, this is another hypothesis যে আমরা দেখেছি বাংলাদেশে যে মেল এন্ড ফিমেল চিলড্রেনের মধ্যে যে ম্যালনিউট্রিশন তার মধ্যে একটা সিগনিফিকেন্ট ডিফারেন্স আছে। ওকে, এই জেন্ডার ইকুইটি আমাদের দেশে অনেক ইমপ্রুভ হয়েছে, বাট স্টিল ইট ইজ has some way to go. There is no difference between the level of education and knowledge of child nutrition among women. If you consider this is null hypothesis, alternative hypothesis can be that the level of education and knowledge of children nutrition among women are associated. Okay, so this is null hypothesis and alternative hypothesis. Simple hypothesis when it completely specifies the distribution of a population. It is called a simple hypothesis. Suppose, for example, that his coin is tossed 30 times, n equals 30, to determine whether the coin is an ideal one. Then the hypothesis p equals 0.50 is a simple hypothesis, since it completely specifies the population distribution. Okay, আপনারা জানেন যে কয়েন টসিং এক্সপেরিমেন্ট একটা বাইনোমিয়াল ডিস্ট্রিবিউশন ফলো করে। কাজেই যখন বলে দেওয়া থাকে কয়েনটা 30 টাইমস টস করা হয়েছে, তার মানে nটা নন। আর যখন বলে টেস্ট whether this hypothesis p equals 0.50, that is p given, n given, so this is simple hypothesis. Composite hypothesis is totally opposite to that. If a hypothesis does not completely specify the population distribution, it is called a composite hypothesis. For example, if in the above example, coin tossing example, if we do not specify that n equals 30, if it is not given, then the hypothesis p equals 0.550 would be a composite hypothesis. Okay, because we don't know the two parameters of the distribution. Test can be on-tail and two-tail. Okay, a test of a statistical hypothesis is whether the alternative is two-sided, such that say null hypothesis mu equals mu naught and alternative hypothesis is mu not equals mu naught. Okay, so the alternative hypothesis actually goes in two directions. If null hypothesis is not right, okay, then alternative hypothesis is true. So what it tells us, mu is not equals mu 0. Consider mu equals 10. It is not 10. So what it can be greater than 10. It can be less than 10, for example. Okay, consider this is a probability function. Okay, so this is a normal distribution in general. I cannot draw it correctly, so this is actually mu. Okay, it is actually in the middle and it is actually equal 0. So when we say that the null hypothesis, alternative null hypothesis equals mu equals mu naught, and when we say that the alternative hypothesis mu, it should be clone. You should write it with clone, that mu not equals mu 0 or mu naught. Okay, so what it tells us, if mu is somewhere here, that it can be greater than that 10. Okay, say mu equals 10 here. If that mu not equals mu 0, then it can be greater than mu 0 or it can be less than mu 0. So that test actually is going in two directions. Okay, in that cases your alpha value, alpha is actually in general we call it 5%. Okay, or in terms of probability, this is actually in terms of probability, this is actually 0.05. So when we have alternative hypothesis like this, that is not equals, it tells us our test is two-tailed, because the alpha, this probability alpha will be in 2 halves, okay? Alpha by 2 is here, and another alpha by 2 is here, alpha by 2, okay? So this value, the area or probability of this area will be half of this 2, alpha by 2, okay? So it will be 0.025. 0.025. If your alternative hypothesis is like this, okay? So we call them, it is a two-tailed test. And if you have a distribution, and if you have only one alpha in here, we call it a one-tailed test. Alpha equals 0.05. Okay, when your null hypothesis is greater than that, mu equals greater than mu0, your testing hypothesis that that normal distribution or test statistic frequency distribution look like this. Another thing is that we call this shaded area as the rejection region, okay? Because if the test statistic value lies here within this area, we will reject our null hypothesis, and this area is known as acceptance region, because we want to accept our null hypothesis based on the value of the calculated statistic, okay? So we call this one the rejection region, যেটার মধ্যে পড়লে আমরা হাইপোথিসিসকে রিজেক্ট করি, আর যেটার মধ্যে পড়লে আমরা হাইপোথিসিসকে অ্যাকসেপ্ট করি সেটাকে আমরা বলি অ্যাকসেপ্টেন্স রিজিয়ন। তাহলে ওয়ান টেইল টেস্টের বেলায় এই ক্রিটিক্যাল রিজিয়নটা একদিকে হবে, ওকে? ফর এক্সাম্পল, যদি আপনারটা হাইপোথিসিসটা লোয়ার টেইল টেস্ট হয়, ফর এক্সাম্পল লাইক দিস, যে আপনার বাম দিকে এই আলফা ভ্যালু একদিকে, তার মানে হলো আপনার হাইপোথিসিসটা যে এরকম অল্টারনেটিভ হাইপোথিসিস মিউ ইকুয়ালস মিউ সে ইকুয়ালস মিউ0, অল্টারনেটিভ হাইপোথিসিস হচ্ছে মিউ লেস দ্যান মিউ0, ওকে? তখন আপনার ক্রিটিক্যাল রিজিয়নটা বাম দিকে হবে, ওকে? আলফা ইকুয়ালস কিন্তু 0.05, তখন একদিকে। কাজেই এই দুটোকে বলে ওয়ান টেইল টেস্ট। কারণ কি, এর ক্রিটিক্যাল রিজিয়ন একদিকে, হয় ডান দিকে নইলে বাম দিকে। ডান দিকে কখন হবে? যদি আপনার হাইপোথিসিস এরকম গ্রেটার দ্যান হয়, আর যদি লেস দ্যান হয় হাইপোথিসিস এরকম যে মিউ লেস দ্যান মিউ0, তখন আপনার ক্রিটিক্যাল রিজিয়ন বাম দিকে, এবং এরকম টেস্ট দুটোকে বলে ওয়ান টেইল টেস্ট। আর যখন নট ইকুয়াল সাইন থাকে অল্টারনেটিভ হাইপোথিসিসে, তখন এটাকে বলে টু টেইল টেস্ট, বিকজ ইউ হ্যাভ two rejection regions in the two tail of the distribution, okay? In general, this is the standard normal distribution, okay, we are trying to draw, or it can be t, okay? We'll learn later, but this is the idea, whether you will use one tail test or two tail test. Forget not to notice that it is actually the alternative hypothesis that actually determine your type of test, okay? One tail test or two tail test. Whether you have to go for two tail test or one tail test, based on the problem you will judge looking at your alternative hypothesis, okay? Do you have any question? Okay, you are good, you don't ask question, so you always understand with the first instance. That is good. Okay, next topic is type of error, okay? The error of rejecting null hypothesis when it is actually true, we call it first type of error, okay? That type of error can be easily understood with this tabular presentation. Okay. For example, in the column we put null hypothesis true, null hypothesis false. The row says null hypothesis accepted, null hypothesis rejected. So when we go to this cell, you see this is null hypothesis true, null hypothesis accepted. So this is a good decision, right decision. Again, when null hypothesis false, we are rejecting it. This cell is actually good decision, right decision. But what is the type 1 error? When null hypothesis is true and you are rejecting it. Okay? That is an error because you are rejecting the true hypothesis. Again, the same time, when null hypothesis is false, you are accepting it, you are doing something wrong. That is type 2 error. False item, you are accepting it. Okay? More serious than type 2 error. Because the true item, true hypothesis, you are rejecting it. You are punishing an honest man. Jahalom, if you can remember. Jahalom was sentenced for 3 years without any wrongdoing by our High Court, based on a case of our anti-corruption unit. Okay? But most of the defaulters are not punished here. But that is a serious offense. You are punishing an honest man. So this type 1 error is more serious than type 2 error. So we fix this type 1 error. The probability of this type 1 error is actually alpha. Alpha, actually, this alpha is called the level of significance, okay? And probability of this type 1 error is that alpha. So we always consider this alpha is equals 0.05 because this is a serious error. So we want to fix it because in statistics, 2 errors cannot be controlled simultaneously. So we want to fix one and minimize the other. So this type 1 error is actually the probability of type 1 error is alpha and probability of type 2 error is actually beta. What is type 2 error? False null hypothesis, you are accepting it. Okay? So forget not to learn that when a dishonest man is free by the court, it is also an error, but it is not of that serious type because a guilty person is released. Okay? A guilty person, he should be punished, but we couldn't. But the benefit goes to that man. But here, the true man is actually sentenced. Okay? So these are the differences between type 1 error and type 2 error. Okay? The probability of type 1 error is alpha, probability of type 2 error is beta. Power of the test, 1 minus beta is actually the power of the test. When we reject null hypothesis, that is false. The probability of rejecting null hypothesis that is false is actually 1 minus beta. So we always want to know this power of the test. Two tests with same alpha can be compared with this power of the test. The better the power, the better the test, okay? So we need this power of the test. 1 minus beta is also called the power function. When you put the value of beta there, that is actually the power of the test. But in general, 1 minus beta is called the power of the function, power function. So another important item is p-value. P-value or observed significance level of a test is the smallest value of alpha for which null hypothesis can be rejected. Okay, so you should remember that the alpha value is the p-value when null hypothesis is rejected. Okay, so for a two-tailed test, if you consider alpha equals 0.05, that is any value smaller than 0.025 is the p-value. Okay, because for that value we can reject the null hypothesis. So if you stay with study and teaching and doing research, this p-value will bother you, okay, if you don't understand it. So forget not then that it is actually the smallest alpha value for which you can reject your null hypothesis. Okay, the decision making is easier for researcher based on this p-value. If the p-value is less than 0.01, that hypothesis is considered as highly significant. The p-value between 0.01 to 0.05 is regarded as statistically significant if alpha value is not given. Okay. These days, the manual decision making is actually not done, as computer is calculating the p-value with some help of the softwares easily. Okay, so decision making will be easier with this p-value. If your p-values lies between 0.05 to 0.1, the results are regarded as toward statistical significance. Any p-value greater than 0.10 is regarded as not statistically significant. Okay, so these are the rule of thumbs, okay, for decision making hypothesis. You have to find the p-value. We will do that manually, okay, using a table. So if alpha value is not given, you have to make decision based on the p-value like this way. Okay, 0.01 is also known as that it is actually 1%. Okay, if it is a probability value, so we must write it with between 0 to 1. Okay, এটাকে আমরা 1% বলতে পারি, হ্যাঁ, for understanding. কাজে এটা যদি 1% থেকে ছোট হয় তাহলে হাইপোথিসিসকে বলতে হবে হাইলি সিগনিফিক্যান্ট। যদি 1 থেকে 5% এর ভিতরে হয় তাহলে বলতে হবে স্ট্যাটিস্টিক্যালি সিগনিফিক্যান্ট। 5 থেকে 10% এর মধ্যে হলে বলতে হবে স্ট্যাটিস্টিক্যাল towards statistical significance, and more than 10% we will call it not statistically significant. But if alpha value is given, for example 0.05, then smaller than that 0.05 is actually your p-value that will reject your null hypothesis. Critical region or acceptance region we have defined earlier, that for the region you will reject your null hypothesis, they call it that rejection region. Acceptance region is the region for the set of possible values of the sample statistic you will accept your null hypothesis. Okay, the test statistic used to provide evidence about the null hypothesis is called test statistic. We have some formulas based on t, chi-squared, f or z test we show you earlier in the first slide. That is the test statistic. We have some formula, okay, like this. This is a z statistic formula. So they call it Z statistic. Okay, so this is also test statistic. It can be T, it can be F, it can be chi-square, but this formula is used to find evidence of the null hypothesis. Okay, so they call it test statistic. So these are all terminologies you have to know that for testing hypothesis. Okay, so do you have any question? Okay, you don't have any question, so you want to go to some example directly now. Testing of hypothesis can be done based on sample. Okay, so one sample mean test. আমরা প্রথমে পড়ব on sample mean test. আমাদের একটা পপুলেশন থেকে একটা স্যাম্পল নিয়েছি আমরা, then we want to test some hypothesis. One sample mean test is used when you have data from a single sample of participants and you wish to know whether the mean of the population from which the sample is drawn is the same as the hypothesized mean. So we need some assumption that the data should be at the interval or ratio level of measurement. That the data should be a number. Okay. Random sampling, the score should be randomly sampled from the population of interest. The score should be normally distributed in the population. Okay. Clearly, assumptions 1 and 2 are a matter of research design and not statistical analysis. Assumption 3 can be tested in a number of different ways. Whether your data set follows normality, you can judge that. Okay, how? You can draw a histogram. Okay, and above the histogram you can place a normal distribution. Okay, normal curve. Whether your data showing approximation to a normal distribution. So when you have a single mean testing, this can be of 2-3 types. Okay, 2-3 types. First one is when sigma is known. Okay, forget not, we are actually testing whether about the null hypothesis that mu equals, for example, 3.2. আমরা মনে করেন যে ধরে নিচ্ছি যে আপনাদের ক্লাসের এভারেজ সিজিপি এটা 3.2 কিনা 2 এর সমান কিনা আমরা টেস্ট করতে চাই। Alternative hypothesis যেটা not equals 3.2. Then first case arises whether sigma is known. From where the sigma is coming? Can you remember? Because this sigma is the standard deviation of the normal distribution. Okay, and we are testing the mean. Okay, so sigma is coming intuitively. Okay, because the normal distribution has 2 parameters, mean and sigma. Okay, so when you are going to test mean, sigma will come instantly. So sigma can be known, sigma can be unknown. The sample size can be large, sample size can be small. Okay, so we have 3 situations here. If your sigma is known, then this formula x bar minus mu0 sigma divided by square root of n will follow normal distribution with 0 mean and variance 1. So it will be a Z test. Okay. When sigma is unknown but sample size is large, that means greater than 30, this x bar minus mu 0 s divided by square root of n will be a normal distribution with mean 0 and variance 1. That is a Z test. Okay. So the difference is sigma, in place of sigma we have S now. Okay. What is S? S is the standard deviation from the sample. Okay. You know it. You know how to calculate this S, right? It is unknown, but it is actually estimated from the large sample when n is greater than 30. But there are situations when sigma can be unknown and sample size is small, less than 30. Okay. So then the formula x bar minus mu 0 divided by s square root of n will follow a t distribution with n minus 1 degrees of freedom. N is the number of elements in the sample. Okay. So this statistic t distribution, এটাকে আমরা আপনাদের স্যাম্পলিং ডিস্ট্রিবিউশনে একটু পড়িয়ে এসেছি যে t distribution. এই জন্য t distributionকে একটু স্মল স্যাম্পল টেস্ট বলা হয়ে থাকে। স্যাম্পল সাইজ যখন স্মল হয় 30 এর নিচে হয় তখন সেটা টি টেস্ট। স্যাম্পল সাইজ যদি 30 হয় অথবা 30 এর বেশি হয় তাহলে সেটা লার্জ স্যাম্পল। সিগমা নোন অর আননোন তখন সেটা জেড ফলো করে, দেখেছেন? But based on the problem given, you have to identify whether sigma is given or S is given. S is the sample standard deviation, sigma is the population standard deviation. So based on the problem in the text, you have to identify what is x bar, okay, what is sigma or S, sample size, and what is the hypothesis they're going to test. So put the values there and calculate the Z value. Okay. When we get the Z value, we call it the Z calculated value. Okay. Then we have to compare that with the tabular value of standard normal distribution with that n, with that alpha. Okay. So that's it. We want to discuss on exercise here. Suppose in a problem sigma is given 2100, n is given 25, x bar is given 13,000. Okay, we want to do a null hypothesis whether mu equals 14,500. This is a book from your reference book on page 422, section 8.5. Okay. So when they also call whether that mean value is less than 14,500 or not. In the problem, alpha value was also given that it is actually 0.01. Okay. So first thing we have to do is to calculate the Z statistic. You see, x bar is given 13,000, mu 0 is given 14,500, sigma is given 2100 divided by square root of n. N is given 25. So we got Z value is negative 3.57. We call this Z calculated. Also alpha value is given 0.01. So from the table we can see, like we did in normal distribution discussion, যে t এর alpha value যখন 0.01 তখন z এর tabulated value হচ্ছে 2.33. 2.33. Okay, so in the test of hypothesis we have 5 steps, okay, to do a test. First thing, you have to set a null hypothesis, you have to set an alternative hypothesis, then you have to calculate the test statistic value, that is, they call it z calculated, t calculated, chi-square calculated, and so on. Then you have to find the tabulated value, okay, based on the alpha value. It is given in the table. আমরা আপনাদের যে z ভ্যালু টেবলটা দিয়েছিলাম সেখানে যদি আপনি যান যে আলফার ভ্যালু যখন 0 1 তখন আপনার z এর প্রবাবিলিটি ভ্যালুটা কত, ওকে, z এর ভ্যালুটা তখন আপনি এটা পাবেন। Next and final step is the decision making. How you can make decision? We have to see whether the z calculated absolute value is greater than z tabulated value or not. If it is greater than, then we should reject the null hypothesis. That is, the average life of the wave phrase is significantly less than the hypothesized value. Okay, null hypothesis is rejected. Null, it is not true. So this is true. Okay. So how we made that decision? You have to take, you see, negative value is here. Z calculated মধ্যে একটা negative value আছে, ঠিক আছে, negative 3.57. So decision making will be easier if you take absolute value in both the cases. Okay, এটার absolute value positive, এটা তো পজিটিভই, ওকে, আর দুইটার পজিটিভ নিতে হবে। তখন যদি z calculated বড় হয়, null hypothesis is rejected, it is not true, this one is true. Very simple. Okay, so this is how decision making is done. Okay, in test of hypothesis you have to set a null hypothesis first, alternative hypothesis, then you have to calculate the z statistic, then you have to find the tabulated value, then you have to make decisions. Okay, do you have any question? If you don't have any question, so we want to end it here. Thank you.